All right, so now that we've learned a fair bit about our ionic compounds, now we're going to move over to our covalent compounds, our second type of compounds that we generally talk about, okay? So our covalent compounds, right? All right, let's go back to our ionic. Ionic compounds, we said that one atom would be stealing the electron, one atom is giving it up. In our covalent compounds, one atom, or the atoms share the electrons. They share the electrons. Oops, electrons. There we go. So in this case, what we're showing is that carbon and hydrogen are sharing some electrons. Oxygen and hydrogen are sharing electrons in water. In ammonia, hydrogen and nitrogen are sharing electrons, okay? So what we're going to try and do is we're going to try and illustrate that they are sharing these electrons. So I'm going to flip forward a few pages in our notes, all the way over to this page here, to start talking about our Lewis diagrams, our Lewis dot diagrams for covalent compounds, okay? So what we do is we write the symbols first, we draw the valence electrons, and then if there are more than two atoms, we find the element with multiple unpaired valence electrons, and we say that it's going to be the central atom. Okay, that's a whole lot of confusing things all in one. So let's start with a simple example, right? In this case, hydrogen, right? Hydrogen, if I were to just draw hydrogen with its dot as its dot diagram, hydrogen has one dot, right? One valence electron. And really, hydrogen can only have two valence electrons because it's only putting electrons into that first energy level. Oxygen, on the other hand, has 1, 2, 3, 4, 5, 6 valence electrons, right? So it wants to get up to 8 valence electrons. So both of these elements want electrons. Their electronegativity is relatively high compared to a number of other elements, right? So they want electrons, so what they're going to do is they're going to share. So this, we have two hydrogens here. Our central atom is going to be oxygen. So we're going to put oxygen in the center, and then every single time that we want to share electrons, we're going to draw a line, okay? So in this case, I'm going to draw it like this, and I'm going to put my extra electrons on top. So in this case, right, one electron from oxygen is shared with one electron from hydrogen. This sharing stabilizes the electrons, okay? So our goal is to pair up the electrons, right? So if we were to have this here, right, we would have a single line here, and that it represents a single bond. Okay, so a single line, right, every time we draw a line, we're sharing two electrons, and there are two pairs, one pair of electrons that is being shared, right? One pair of electrons is two electrons total. So in this case, right, this carbon and this carbon have one electron each that they decide to share to help stabilize them, okay? If we have two dashed lines, right, two dashed lines is called a double bond, okay? So a double bond, we have four electrons that are being shared, and we have two pairs. So in this case, right, this carbon, contributed two electrons, and this carbon contributed two electrons, and they decided to share each of their electrons. So this C, double bond C, represents 4 electrons total and 2 pairs, okay? Let's go on to the next page. Here, and this didn't print very well, so I'm going to have to rewrite it. It's going to be H, C, line, 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 C, line, H. We have 3 lines, so 3 dashes or 3 lines is called a triple bond. Okay, a triple bond has 6 electrons and 3 pairs that are getting shared between them, okay? So these are our 3 different types of bonds that we can make. We can make a single bond, that's just 1 line. We can make a double bond, which is going to be 2 lines, and we can draw a triple bond, that's going to be 3, okay? We can also draw lone pairs. When we draw lone pairs, right, it's just sitting on 1 atom, and we're going to have 2 dots. That is a lone pair of electrons, okay? So I think the easiest way to kind of start to understand how to draw these Lewis diagrams, we're just going to start working through some of them, okay? So if I look here at HCl, right, H I know has 1 valence electron, and then Cl has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7, right? So the first thing that I'm going to do to draw these dot diagrams is I'm going to take and write my elements and count how many valence electrons I have. So I have 1 plus 7, that equals 8 valence electrons. So what I can do then to start drawing my Lewis diagram is I'm going to draw a skeleton first, right? So I'm going to draw that skeleton that's going to connect my atoms, okay? And this represents 2 electrons. So I have 6 more electrons that are left, right? 8 minus 2, we got 6 electrons left. I can't put them on hydrogen, right? Because hydrogen has 2 electrons that it's sharing here. Hydrogen can only have 2 electrons. Okay? So that's a rule that we're going to want to start to remember, right? Hydrogen has electrons that are going into the first energy level. The first energy level can only fit 2 electrons. So in this case, we've got 2 electrons that are getting shared in that first energy level. So it's going to have those 2 electrons. We still have 6 electrons left. Chlorine, right, does want electrons. So we're going to put 1, 2, 3, 4, 5, 6 electrons onto chlorine. So what we can see now, right, hydrogen has a full valence in the 1 first energy level, and chlorine, right, we have 2, 4, 6, 8 electrons. Chlorine is happy as well and is stabilized by having 8 valence electrons. So in general, right, most of our elements want to get to 8 valence electrons. Okay? Let's now look at N2. So N2, right, we've got 2 nitrogen atoms, so N, 1, 2, 3, 4, 5, and N, 1, 2, 3, 4, 5. We've got 10 electrons total, right? I'm going to count that I have 10 electrons to put on here. My 10 electrons, I'm going to start by just drawing a skeleton. If I draw this skeleton, that's 2 electrons that are gone. I've got 8 electrons left. So let me give 4 and 4, right? 1, 2, 3, 4. 1, 2, 3, 4. But now, if I look at this, right, this nitrogen only has 6 electrons around it, right? It's got 2 that are in this bond, and 1, 2, 3, 4. So 4 plus 2, that's only 6 electrons. It's not stabilized until it has 8 electrons around it. So this nitrogen here is going to yell over to this nitrogen and say, hey, let's share. So it's going to take these 2 and share. Now it has 1, 2, 3, 4, 5, 6, 7. Still not quite there. So it yells again, hey, let's share. Now, right, we see 1, 2, 3 bonds. So our bond here is going to be 1, 2, 3, N, and then we look at it and we say, this nitrogen has 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons around it. It's stabilized. We look at this nitrogen and it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, right? By sharing electrons, all of the atoms can become stabilized, okay? So let's do one more here. I'm going to skip over CCl4. and I'm going to go down here to NH3. NH3, N, we would have 1, 2, 3, 4, 5, and then H, we've got 1, H, we've got 1, and H, we've got 1. So we've got 5 plus 1 plus 1 plus 1. That's 8 electrons total. And I'm going to start by building a skeleton, right? I'm going to build my skeleton with nitrogen in the middle because hydrogens always like to be on the outside, okay? Hydrogens always like to be on the outside because it can only share 2 electrons, right? So hydrogen will attach to nitrogen. We've got 2, 4, 6 electrons that are on there. I've got 2 more electrons to go. All of these hydrogens can't have any more, so that means that nitrogen now is going to get electrons. So my next video, we'll talk some more about these.